Hello everyone, welcome back to the 5 Minute Tech channel. Today we will be talking about Microsoft Agent Framework version 1, which was released recently, and we will talk about how it is a combination of AutoGen plus semantic kernel as a unified platform. And Microsoft Agent Framework 1.0 deep dive will be doing in along with discovering its features, architecture, workflows, MCP, and the real-world usage of Microsoft Agent Framework. So Microsoft Agent Framework is a production-ready agent engineering for .NET, Python, workflows, and multi-agent systems. It has different features, some of them being it is production-ready 1.0 release of Microsoft Agent Framework with stable APIs and long-term support. It has a unified foundation built in with from semantic kernel and AutoGen ideas, and it supports single agent workflows, multi-agent orchestration, and local model scenarios. The Microsoft Agent Framework supports different stateful workflow engines, multi-agent coordinators, unified middleware. The MCP tool integration is present in it, along with .NET and Python SDKs. It is made to scale for the enterprise, and the Microsoft announced Agent Framework 1.0 recently as a production ready release for both .NET and Python. The version 1.0 is a unification of Microsoft's agent direction into one framework that spans simple assistants to orchestrated multi-agent systems. Why Microsoft built this? The system is built, as we talked about, around semantic kernel, which brings in the enterprise features such as state, type safety, middleware, and telemetry. The AutoGen, as you know, brings in the powerful multi-agent abstraction and orchestration patterns. The agent framework then combines both of these and adds graph-based workflows for explicit execution controls. So Microsoft explicitly describes agent framework as a direct successor to semantic kernel and AutoGen. So the framework is the main path forward for building Microsoft tech stack based agentic applications. Now what changed in our Microsoft Agent Framework version 1.2? It has its own versions, and now it is matured into or a stable tested feature surface with compatibility commitment going forward with version 1.0. It has core single agent abstraction into production ready in both .NET and Python. Stable workflows and orchestration patterns are now central to the framework story for the Microsoft Agent Framework 1.0, and it also signals the movement to production posture from a Microsoft perspective. For enterprise teams which were already working on the agentic framework from Microsoft, stable APIs and support commitments comes with version 1.0. Microsoft Agentic Framework core architecture involves your application UI, which is your CLIs, copilots, the web and the APIs which are exposed on the top of, which is your agent framework app, which is having the agent and the workflow layer, which interacts with agents, middleware, and session state. Agents being your prompts, tools, and middleware being your safety and the logins which you build into your agentic system, along with session and state, the threads and the history which are maintained in the session. Also, we have certain tools which in combination with MCP does the functions and interacts with the servers, and it has the memory context which is saved via key value pair or a vector database store or things like that. It also has the model providers in terms of Foundry, Azure, OpenAI, Anthropic, Bedrock, Gemini, or your locally hosted Ollama. Now think of this framework layers in terms of model client at the top, the agent abstraction above it, workflow orchestration above that, and then the application specific tools, policies, and the UIs around it. This layered model is exactly why the framework fits both with simple copilots and also a larger agentic systems. Now, what is the difference between the agents and the workflows? We use an agent for an open-ended conversational tools using tasks, whereas we use workflow when execution steps, routing and branching must be explicit. If a task is deterministic enough for a function, Microsoft recommends using a function or instead of an agent. Not everything has to be done by an agent. Prevent overusing the agents, and it should start with the multi-agent. We shouldn't start everything with the multi-agent everything. It should start with functions. What is the actual purpose of writing a specific agentic system or agentic code, and that then add agents only when reasoning and the tool selections are generally needed. So that's how you can distinguish. Now, single agent foundation involves the stable core agent abstraction for .NET and Python, the first party connectors for Microsoft Foundry, Azure, OpenAI, your Anthropic Claude, Amazon Bedrock, Google Gemini, and then the locally hosted or the server hosted Ollama. And it supports streaming, multi-turn conversation tools and session based state evolution. The framework is not tied to one model vendor. It can be combined with different kind of vendors. Provides flexibility provider flexibility is important because it shows the framework can fit cloud first or your hybrid or your local first architectures as well. Now, memory and control, it has the agentic logic, then the middleware and the memory and state. The middleware can intercept, transform and extend execution for safety, logging, compliance and custom behavior. Your memory is pluggable and can include conversational history, key value state and vector retrieval. Documented memory backend includes Foundry memory, your Memo, Redis, Neo4j and custom store. Now this is where the framework becomes your enterprise ready rather than just being a prompt orchestration. You can insert policies, observability without rewriting your prompts, and you can persist those context beyond a single chat over a period of communication which you do with the agent. Now, workflow engine is mostly like a graph-based workflows composed via agents and functions into deterministic and repeatable processes. It supports branching, fan-out, convergence, and long-running execution with checkpointing and hydration. Human-in-loop scenarios are supported through request-response style workflow controls, wherein you provide the input, it has a classifier. Then there are specialists which work upon the classifications, and they can work in parallel along with an approval layer, and then the final aggregator is in place. The workflows are the biggest architectural addition beyond a simple merge of previous frameworks. They give the developers explicit control over execution order, which is critical for regulated or auditable business processes. Now we are talking about all these things in terms of Microsoft Agent Framework, which also includes your multi-agent patterns, which are essentially across the industry, but it is also relevant in Microsoft Agent Framework version 1.0, which involves your stable orchestration patterns including sequential, concurrent, handoff, group chat and magnetic one. These are the agentic patterns. These patterns includes or supports your streaming, checkpointing, pausing or resuming and human approvals for long-running workflows. The framework is intended for fleet of specialized agents, not only one assistant at a time. Now, multi-agent scenarios or systems is a decision choice and is not by default. You may need to apply or not apply depending on your use cases. The sequential works well for draft and review flows, concurrent works for parallel specialist analysis, and handoff or group chat pattern fits collaborative reasoning. So based on your need, you need to adapt and adjust your multi-agent architecture. Now MCP, A2A and declarative definitions are also part of how Microsoft Agentic Framework works. MCP lets agents discover and invoke external tools exposed by MCP compliant servers. A2A, agent to agent, is intended for cross-runtime structured agent collaboration. Though the version 1.0 of Microsoft Agentic Framework announcement says A2A 1.0 support is coming soon, it is not yet there. Agents and workflows can also be defined declaratively in YAML for version control configuration. And the open agentic web angle of the framework includes your MCP matters right now, because it gives your agent a standard way to connect to tools, and A2A matters set strategically because it points towards the cross framework collaboration. We will be working on creating a simple application which will be a web API that will scan the local base path, and it will have a rule engine that will detect risky patterns, and an agentic framework agent that explains the risk prioritization finding and suggests the fix. We will be calling this system as your local code security auditor, and the security auditor will audit the application code which we will be providing. So we have created a folder for security auditor. In this folder we'll be creating the .NET project. To start with, we'll go ahead and launch a terminal, and in the terminal we'll be creating a new solution for the security auditor, which will come like this. Followed by that we will have a web API. The web API will be called security auditor API, and it will have the project file for it. Following that, we will have the security auditor application project. The security application auditor application project will be something which will have your different classes and stuff. Then we will have the class library for the domain for the model. So I'll create the security auditor domain project, which will have different set of models. Now we will go ahead and create the add the projects to the solution file. So let me do that one by one, wherein I'm going ahead and adding this project to the solution, and then finally the domain project, and also we will go ahead and add the project reference as we need it. We are adding the project reference of the project which we have created. So this is done. We have added the project reference as well. Note that I'm creating this with the use of Visual Studio Code. You can use Visual Studio for doing these changes. That will, if it is easier for you. So I'll go ahead and now open the security auditor API CS browse. This needs certain modification. I'll bring in the references. So let me just put in the reference, wherein I'm getting the Microsoft extension AI Ollama reference here, along with the Microsoft Agents AI and the normal swashbuckle ASP.NET Core. Also, I'll go ahead and update the security auditor application proj CS proj, and this project I will be updating with the code, wherein I am bringing in the Microsoft Agent AI extension or the reference, along with the Microsoft extension AI.Ollama. Now following this, I will be also making the project CS proj change in the domain project as well. It will be a little more simpler here. Let me just close this and add this here. And then following that, I will go ahead and add the models folder for our domain model. So I will go ahead and new folder models. I will delete the class file and go ahead and add the first model, which is the severity. Now remember, we are doing a local code auditor application, which will audit the application for any code vulnerabilities. So I'll go ahead and add namespace. Along with this, I will also add a class file. There is an extension which I have not added for C#, which you can add in the Visual Studio Code, but I will go ahead and do the simple implementation so that you will not see these red symbols. It will be more formatted one. Next one is audit finding CS file, which will again be a model. So let me go ahead and add this file as well. This will find the results, what is audited. This has certain set of properties, along with your file scan result. For each file, what is the scan result is something which will be thrown through this set of properties in the final scan result, and then the audit report model will be set of properties, will give us the report of what was the outcome of the audit. And next we'll move on to the interfaces for our application layer. So I'll collapse the domain and then move on to the, I'll first delete this class name, and in the application layer add a folder called interfaces. Now these interfaces are something which is related to trying to understand from a security or code auditor perspective on what are the things which are there in the code. So iCode repository reader, now this will have the code wherein it will read the files which are there in the specific location. Just save all these things, which will read the file for the code, and then pass the input of the file, content of the file for scanning. Another interface will be your rule based scanner, which will provide the set of rules, or the scanners. It will provide the scanning part. We will take the file as input, and any cancellation if we want to do in between the execution itself as a cancellation token. Now there is an analyzer, which we will be an agent security analyzer, which will be having the agent security analyzer will be doing your analysis of the set of files that we have provided. Now we will move on to the services for the same thing, for which we have written the interfaces. So we'll create a new folder, services, and then the code repository reader. So we will add the service for it, and this service will have the actual code, inherit from the interface, and implement the read file async. Now this is pretty standard code, so I'm just putting it in here. In the interest of time, rather than typing the code line by line, I'm just providing what is the intent of the code here, which is pretty basic, simple functions in place with certain security. So this is a class for the regex rule based scanner, and it will go ahead, and you can bring in other way of scanning the code. I am using a regex based pattern here, and it is scanning the file and trying to generate the findings from it. So that's the pretty much standard one. The next service is the agent security analyzer service. This also has an interface which we will be implementing, and this will be implementing your function which we have defined in the agent security analyzer, which is the analyze async. It will create the chat client, the Ollama chat client, which comes from your the difference which we have for Microsoft agents. And then it goes ahead, takes the URI and the model which we will be defining, and then it provides the set of instructions, prompt, and on that basis we will be getting the output. So the work happens in your agent security analyzer, wherein the agent comes in the picture through our Ollama based model, which we will be using as the Ollama 3.2. Next service is our security audit orchestrator. So we'll go ahead and add that file, which is your security audit orchestrator file. Now security audit orchestrator file takes in your domain models and generates the output, and executes whatever we have provided with the report which will be showcasing to you. So moving on, we have the program.cs files which needs to be updated for the API project. First save all these files, and in the program.cs we will be making certain changes, removing the auto code. So remember, here we should have the Ollama running, which I'll show you. We will be, as I mentioned, we will be referring to the Ollama 3.2 as our model. So let me go ahead and update that as well, and we will be creating a different set of controllers. So let me first add the folder for controllers, and in this controller I'll go ahead and add the health controller. So first of all, to see if everything is working fine, we need a health check controller. Following that, we will have the auditor controller, which will be doing the auditing part which we have been talking about. This again calls the service, the security auditor application service, and calls the method of scan, which we talked about briefly. And we will update the app settings file, which is more or less pretty generic and provides the endpoint and the model name, along with the dev setting, the development JSON as well, which is the same which we have right now. Now this is the pretty much the setup. We also need to do one more setup in terms of having certain samples. So let me go ahead and add a folder for a sample. Now this sample means we will be having some code snippets here. So let me go ahead and add a folder here which is a vulnerable sample, which needs to be scanned by the system. So if I add a vulnerable sample, and in this I will add a dummy app setting file, and let me add the dummy app setting file, which will have a content like this. As you see, this is a dummy file which will have some hard-coded text file, so that the scanner, the auditor, will check and give the input around what is wrong in this code. We will also create a controller here for scanning, so I'll add a controller file. Now this controller file has flaws which should be identified by the code. As you see, there is a username and password which is present here. Then we will also have a repository class in here to showcase that area as well. And if you see here, it is having non-parameterized select query, which is directly passing the username here. So these are some of the flaws which we have built in. And also one crypto helper is there, one more flavor of a file which has certain flaws, which we will give it to the LLM to find out on what are the flaws in these kind of files. Just for the check-in purpose, I will add the readme file here. So let me quickly add the readme, so that when I add these files, there will be certain steps which could be followed. Now the next step is to get the Ollama, and you can get the Ollama in the Docker, or you can do it through a direct install of this. I do not want to install Ollama directly into my system, so I'll be doing in terms of Docker. So let's see the Docker commands. So this is the Docker command which you can run. Since I already have a Ollama container running, so it will show the error. So basically I'm running the Ollama on 11434, and that's why it is showing me error. The next command is to pull and run your Llama 3.2, which I'm already doing, so I will not be running this command as well. So let's go ahead and now run the application, since we have both Ollama and Llama 3.2 running. Now the next step is to do a .NET restore, and it has succeeded with 2 warnings, following which what we will do is to run the API project, and which is through this command line. And I see that it is trying to run the API project now, and it is in running mode, and it is running on port 5266. So I'll go ahead and open this HTTP localhost on port 5266. So our application is launching on 5266, and I'll go ahead and first check the health of it, and we see it is healthy. It is showing healthy here. Now let's go ahead and scan this report. For that we will have to put the body in place. So this is the body of the API. We provide the path, we say include AI analysis true, and the max files will be usually scanning will be 50. Now these are the parameters which will go into the API for the scan. So let's run this. As you see, it has come back with the result, and it has given us the response as findings, and the rule IDs, specific rule IDs have been hit. The first one is your SQL query built with string concatenation, as I was showing you, possible SQL injection risk. And then we have the weak in cryptographic indicator in md5.create, and then we have the weak cryptographic indicator in the cryptohelper.cs, and then there are certain recommendations which are coming through. So this is what security auditor is doing based on the Microsoft agentic framework implementation using a locally hosted model on Ollama, which returns certain set of results. I hope you like this video presentation of Microsoft agentic framework. If you like, press like and subscribe to the channel. Have a nice day.